So now we want to put together everything we've learned for an application problem. We have a researcher for Consumer Reports tests a large number of home ovens that are set to 350 degrees Fahrenheit. The actual temperatures of the ovens were normally distributed with the mean, and I highlighted this, a mean of 348.1 degrees Fahrenheit and a standard deviation of 6.3 degrees Fahrenheit. So this distribution is shown below, and the areas are not equal in size, right? You can't use symmetry for this. Okay, so we're going to find our missing values. All right, so again, these are like a puzzle, so you have to figure out which way you want to tackle it first. This particular one, I don't think we have a lot of options. I think we're going to have to find this right-hand tail over here because we have the x value. And when you have the x value and you want the area, that's right here, right? We put in our mean and our standard deviation, our mu and our sigma, and then we're going to use our x value and the area. And this symbol, remember, can go either direction, a less than or a greater than. Okay, so let's go to StatCrunch, first thing. I still have it on from a previous problem. Okay, so we're going to make this be a mean of 348.1 and a standard deviation of 6.3. First thing you got to do is change those. And then we want it to be a greater than. We want it to point to the right because we're looking at a right tail. And then we're going to put in the value of 353.654. Oh, not there though. No. The areas go to the right of the equal sign. So we always put the values to the left, right? Area goes to the right of the equal sign. X values go to the left of the equal sign. And we want it to point it to the right, so that way it'll shade to the right and be a right tail. So I'm going to click compute, and there we have it. So we know that that area is 0.189. And then I'm just going to write that on my paper real quick. So x greater than 353.654 equals 0.189. So this is this answer right here. And this is what we would box. There's the work. All right, so now we know this area and this area. But remember, the three areas add up to 1. So we know this left tail area over here. This has to be 1 take away 0.764, also take away 0.189, right? This green one that we just found. So if we take away the new one we found plus the other one, we'll have what this tail is because all three of these areas add up to 1. Okay, so this calls for Desmos. So let's go grab Desmos. We have an old problem in there. So we're going to take 1 minus 0.764, take away 0.189, and we get 0.047. So that's our answer for the left tail area, right? So that left tail area is 0.047. Okay, now we know an area. We're looking for the x value, right? When you want to find an x value from the area, you put in your mean and standard deviation, you put your area always to the right of the equal sign, and it will give you the x value. You just want to make sure this points in the correct direction. All right, so let's go back to StatCrunch. We know the area right here. So we know the mean and standard deviation are put in already. We're going to put in the area of 0.047, but we don't want it to point right. If I point right, that's not right. That doesn't look like it looks on the paper. I want it to be a left. Now, if I do that right there, it messes it up. So I have to retype in my area. So it's okay if it happens. Just don't freak out. Just retype it. So put your area in, pick your direction. You want it less because you want it to be pointing to the left. It's a left tail. And then click compute. And we get 337.5. And I think we're supposed to round to 1 decimal place. So 337.5. So the probability that x is less than or equal to 337.5 equals 0.047. So this number right here is 337.5. That's the answer we were looking for right there. All right, now we're going to provide interpretations. So the first thing it wants us to interpret, and you have to pay attention when you're interpreting to which direction we're going. So they want x2 and a3, which is this side over here. All right, so first thing we're going to do is take our area and turn it into, oh, and we're doing a proportion way. So that's why we're going to take the area and turn it into a percentage. So we'll say 18.9%. And then what was this? Ovens, of the ovens? Right, of the ovens. Of all home ovens that are set to 350 degrees Fahrenheit will have temperatures more than, right? We have to have a direction word, right? Temperatures above, right? Or more than, right? We need direction words. It's not the value, it's more than the value, it's the tail. Right? So above 353.6, oh, 654, I gave all the decimal places for degrees Fahrenheit. Right? So we have to make sure we have our direction word. You can't just say have a temperature of that value. That's not what it is. It's above that value. It's this gray tail over here that you're describing. Okay, now let's provide an interpretation. This time we're talking about the middle. So they're saying, hey, that middle area, that is Z1, Z2, and A2. So this is the center zone, right? The between zone. So, and now we're doing it as a probability. Right? So a probability is saying if we choose a single random oven, right? If we select a single random oven, the chances, oh, random oven set to 350, right? Of course, ovens that are not turned on are cold. That'll be a different story. Set to 350, set to 350 degrees Fahrenheit. The chances it is between, oh, that we have to have that direction word. Let me make it pink. Between, right? Because we're talking about the middle zone. 350 or 337.5 degrees Fahrenheit and 353 point, I'm going to round that, 353.7. 353.7 degrees Fahrenheit is 0.764. So again, we have our direction word. This one's a between, so it doesn't have as many options as the left tail and the right tail. The left tail and right tail have tons of words. Less than, lower than, below, you know, or above in this case, greater than, above, more than, right? Between is pretty much just between. But you have to make sure you say it, right? You can't just say these two numbers. You have to have a word that gives you the direction. And again, this is the proportion way. We start off with the percents when we're doing proportions. So we turn the area into a percent and go from there. When we do a probability, we talk about a single random thing and then talk about the chances of it being where we are trying to discuss. So pay close attention to what zone you're trying to explain and pay close attention to the particular one you're trying to do, proportion or probability. And if you are not told specifically, it means it doesn't matter. It means you can do either one, right? Either do it as a proportion or do it as a probability. It makes no difference.